Welcome to Spring LIB.
Let's begin with an observation. Let's fix m. And let's say that n is the floor of the cube root of 3. Then by definition of floor, n must be the integer such that n is lower or equal than root 3, the third root of m, and that's strictly lower than n plus 1. Now if we cube every term, we see n cubed is lower or equal than m, which is lower than n cubed plus 3n squared plus 3n plus 1. So m is not unique. Every m between n cubed and n cubed plus 3 plus 3n squared plus 3n plus 1 satisfies n is equal to floor of cubic root of m. Now, how many such m's are there? Let's compute the distance between n cubed and n plus 1 cubed. That's of course, well, the upper bound minus the lower bound, so that's 3n squared plus 3n plus 1. Which means that, let's call this L, there are exactly Ln numbers m such that the floor of the cubic root of m is equal to n. And those Ln numbers are exactly those that are between n cubed and n plus 1 cubed. So just to make it clear, let's plot this. Let's list these numbers. So let's say n is 0, then ln, you just compute it by substituting n, is 1. And in fact, there is only one value of m such that the floor of the cubic root of m is 0. And in fact, that's 0. Similarly, if n is 1, there are 7 numbers that do the job. And of course, those are 1, 2, 3, 4, 5, 6, and 7. That are exactly the numbers between 1 included and 8 excluded. Then again, if n is 2, there are 19 numbers, and those are all the numbers between 8 included and 27 excluded. And again, if n is 3, there are 37 numbers, and those are exactly the numbers between 27 included and 64 excluded. And so on. So far we've just computed how many values of m there are such that the floor of the cubic root of m is given n. So now let's use this information. Let's write the sum of the m of the floor of the cubic root of m. Let's write it this way. Let's sum over the values of n, and those are the values that floor of cubic root of m takes. So 0, 1, 2, 3, and so forth. So let's write over n, and then of course we sum over all the m's such that cubic root of m, when you take the floor, it's n of the same thing. So we've just rewritten the exact same quantity, but just introduced a double sum. So this is the sum over n, the sum over m such that the cubic root of m, when you take the floor, is n. But now by definition, in the inner sum, m satisfies that condition, so that just becomes an n. But now n does not depend on m anymore, so we can move it in front. So we have the sum over n, and then the factor of n that comes in, and then the sum over those m's such that floor of cubic root of m is equal to n of 1. And of course, what is that? That's the sum n that multiplies, well, we're summing once as many times as there are values of m such that the floor of the cubic root of m is n. And we've established that exactly ln. But we have the formula for ln, we computed it previously. That's the sum of n that multiplies 3n squared plus 3n plus 1. Okay, now let's say we finally have the sum of floor of cubic root of k for k that goes from 0 to m. So when k is equal to m, we're going to have an integer number, the floor of cubic root of m, which is the highest number we can obtain. And we've established that that's 3n cubed plus 3n squared plus n. But then we also have eventually some of the numbers which are outside of the strip. So let's write those as k that goes from cubic root of 3 of m plus 1 to actually m of that quantity. But now this quantity is, because we're looking at just this particular strip, this is exactly the floor of the cubic root of m. So let me denote with big M these quantities, just so that I don't have to write it every time. And now we can simply write, well, the first sum is just a sum of monomials, and we have formulas for those, which is this sum here. And then we have the remaining term. So the thing in green is just equal to big M, and it does not depend on k, so we can move it in front. And then multiplies, well, we're summing ones from big M plus 1 to m. So there are exactly little m minus big M numbers there. And this is the final formula, where again, big M is just shorthand for floor of cubic root of m.